What is going on, everybody? Welcome once again to Building Stuff with Nova. We are, as you can see, not in our normal place for those who are returning, but let me say welcome to people who are brand new. This is the place that we like to refer to as your virtual makerspace, if you will, your mastermind, your ideation laboratory. For all of you who've been coming, you know this is where we build together. I am your host, Dr. Nehemiah Mabry, but you know what? You can call me Dr. Nee. I'm your lab partner. I'm your friend. We go out, we hang out, we just chill together. Sometimes I'm your mentor, other times I'm your mentee. At the end of the day, it depends on what we're doing, and as long as we're building together. So I need to know who is in the chat. Do me a favor and drop in the chat if you can hear me loud and clear. Drop some exclamation points because that's how I'm feeling. I hope you're getting some of this enthusiasm that's coming from me right now. I need to see some exclamation points in the chat. Shout out to everybody who was live with us on Twitch, our normal location, as well as YouTube. I see a clockwork over on Twitch, dropping the Kerbal Space Program, the little Kerbins there. Thank you for that emote. Peach Elliott got some exclamation points coming. I'm looking over on YouTube. I see our familiar face. I see that Opal guy hanging out with us. Nova is there. Nova, how are you doing? Are you excited, Nova, to be on location? Because we're building with you, right? And we got a guest today that I'm going to introduce here in just a second. But I need to know who's there. I see. Who do we got? Hugh Mong, I see you coming in clear. Thank you for letting me know we're coming clear. Whenever we go and we change our setup, we want to make sure our tech, our audio, everything is good. And I'm glad you can hear me. And most importantly, I want to make sure that our guests can be heard because we're going to be doing something really cool in just a little bit. I see you, Razzle Dazzle. Yes. Shout out to you watching. Grateful for the broadcast. Super grateful to have you all here. This is a place, again, as we say, we come every single weekday on Twitch. We've been at 4 p.m. Eastern on Mondays and Tuesdays in this month. But generally speaking, we come live at 1 p.m. Eastern on Twitch. But today, shout out to the YouTube family. Shout out to people who are live with us. The building committee is like what we refer to people who've been here anytime longer than 2 seconds. So guess what? If you've heard that entire intro or any parts of it, you're a part of the building committee, all right? So I want to tell you all really quick what we have coming up as a finale before I get into the agenda. Matter of fact, we can pull the agenda up right now so you all can see what we have coming. But I want to remind you what we've been reminding you of for the last, couple of weeks, and that is our application is open. What is this application, Dr. Nee? What is it? Well, this is the application for our grand finale happening at the end of October. We have been designing on a weekly basis, as you all know who've been here, a 4-part engineering escape room. And so we're going to be bringing together a lot of different creative and extreme people who are enthusiasts, people that stream, but we also want to bring at least one of you, someone who is a part of the community that's been watching, that's been contributing. So look at Twitch. We're dropping the link right now in the chat. Nova is doing it. You go over to our Twitch channel, click on the link, and then you submit your application. And if you are selected, guess what we do? We fly you to Boston. We get you a hotel room for the 4 nights that you'll be there. You'll get to meet yours truly in person. You get to meet the entire Nova team. You'll get to be a part of the team that helps solve our 4-part engineering escape room. And this is going to be great because you already know we're going with the theme and the narrative of Y3K. And it's our job. And it may be your job in person to help retrain the algorithm on all of the engineering principles that we've been covering throughout the summer. So if you think that's cool, if you think that's dope, I need to see some emotes in the chat. I need to see some fire. I need to see some cool. I need to see some expression. That includes you, YouTube. It's not just for Twitch. We want you to come over there and click on the link, but it's for anybody that's watching right now. Make sure you know that we want you to apply because we only have, a little over a week left before the deadline closes. We've made the deadline September 27th, and that link gives you the opportunity as herself to be a part of, potentially in person, our finale, our climatic, our pinnacle event for Building Stuff with Nova. So thank y'all so much for bringing the love. Peach Elliott is dropping the hundreds. Herself got the fire. Razzle Dazzle has the fire coming. Yes, we see you, Ethics. Shout out to Rose. Hello, everyone. I love it, Kelly. Thank you for the exclamation points. I'm super excited. All right, cool. All right, so make sure y'all go do that. And I may plug it one more time before the end. Who knows? Because we got a packed show for you today. But I just want you all to understand that September 27th is the last day, the deadline for you all to get your information and to be considered to be that person that we fly to Boston and participate in real life for our 4-part engineering escape room. Super happy that you all are aware of that. Now, without further ado, let me talk about what we have for the agenda. I'm going to introduce really quickly in a second our guest, Dr. Laura Bottomley. You see it right there on the agenda. Then we're going to get into this thing about sensors. We're going to talk about sensors. And of course, you see the title. We're talking about building your own light-up shoe. And I remember getting my first pair like it was yesterday. And so we're going to break that down, and you're going to see what goes into that. And then, of course, I'll circle back and let you know what's more to come. But with that being said, I'm going to go ahead and jump into my intro of Dr. Bottomley. Now, Dr. Laura Bottomley is the Director of Engineering Education at NC State University in the College of Engineering and a special advisor to WMEP, which stands for Women and Minority Engineering Programs. Now, she's a trained, professional, experienced electrical engineer and grandmother to the smartest granddaughter ever. And I heard that was scientifically verified, the smartest granddaughter ever. She has taught everything from kindergarten all the way up to grad school. So this is going to be really, really fun. And she loves soccer. She loves rocks, and which I already told her about our stream yesterday. You know, that was a rocking stream for real. All right, she loves rocks, she loves birds, and she loves to travel. And so, without further ado, I need everybody on YouTube, everybody on Twitch. I need some energy in the chat. Go ahead and drop your emotes, drop your emojis, drop the fire. Let's put our hands together as we get ready to introduce to some and present to others, as we say, none other than our guest today, Dr. Laura Bottomley. There it is. It's coming in. How you doing, Dr. Bottomley?
I'm doing great because I'm here with you.
You're doing great?
Yeah.
Okay, I'm doing great too. Now, y'all, let me know if you can hear Dr. Bottomley good. We want to make sure, drop a 1 in the chat if you can hear Dr. Bottomley well. Drop a 1 because we're going to be getting busy here with our nice little, as I like to say again, virtual makerspace. We're going to get this virtual makerspace going. And I just want to ask you really quick, off the jump, what are we going to be doing today?
So I've been, as part of my job at NC State, I teach freshmen, right?
Okay.
So I've been looking around for things that they needed to know about.
Okay.
And I realized that sensors have become really big.
Yes.
They're all over everywhere. They're part of the Internet of Things. Mm-hmm. So there's a sensor there are multiple sensors in our televisions, our refrigerators, our light bulbs, our cars, everywhere.
Wow.
So I thought I need to learn a little bit more about sensors. So that's what we're going to talk about today.
We're going to talk about sensors today, y'all. And I didn't know that we had sensors in our television and everything. So they're monitoring us. This is part of, like, I wouldn't say they. I don't want to get
no, it's not that. It's not that.
But it's more so data is being captured through a number of stimuli through sensors.
Yeah, okay. And the data, it may not be what you think about.
Yeah. Okay, cool. So we're gonna get busy today. I see the love in the chat. Shout out to everybody. Shout out to you, Rose, on YouTube. Thanks for letting me know that you can hear Dr. Bottomley well. Razzle Dazzle, we see you saying hi, Dr. Bottomley. Okay, where are we gonna start? We got a nice little makerspace here.
So how about we start here?
Shoes.
Yes.
We talked about shoes. Are these my daughter's shoes?
I don't know. Do they fit?
I mean, number 4. They look like she's always losing a pair. I don't know if
It could be. No, I bought these separate. Don't worry.
Okay.
But you may not realize the shoe's got a sensor in it.
So these are sensors in the light up part.
So the light. I mean, these are LEDs, right?
Mm-hmm.
But something has to tell the LED to light up.
Right.
So what's it sensing?
The kid running around in the park.
Yeah. So it's sensing movement.
Okay.
Right?
Yeah. So are these basically, is it based on, I guess, the impact of the shoe hitting the ground, basically?
Yeah.
Okay.
These are simple. You could design it so that, I mean, when it hits, these light up. But you could design it so that if it hit gently, a couple lit up. If it hit real hard, lots lit up. You could, you could make really cool.
So do you all remember, first of all, we have a video on demand that you go and look at where we did some custom LEDs with Becky Stern. So you all make sure you check that out. But I'm curious to know, chat, let me know if you ever owned a pair of these. I remember owning a pair of these, Dr. Bottomley. If you own a pair of these, drop it in the chat. And we're going to see what's inside here.
Well, don't you want to find the sensor?
I absolutely want to find the sensor.
All right, let's see.
We got some, we're about to go ahead and get busy, y'all. We got some tools here that we can basically use to take this apart, right?
Maybe.
I'm
I'm checking to see whether you can do this or not.
Well, you know what? I'm going to tell you something, Dr. Bottomley. I had a number of opportunities to show our building committee how competent I am when it comes to steady hands.
Excellent.
And I don't know if I always pass the test. I'll say that. But we're going to get busy here today. Shout out to Austin behind the camera. We got Austin behind the camera today, y'all. Show Austin some love. And while we're trying to destroy this shoe, Dr. Bottomley, how did you get into engineering?
So I became an engineer because I wanted to be an astronaut.
Oh, you want to go to space?
I did. I wanted to go to space.
Okay.
And so I thought, well, if I'm going to go to space, being an engineer is a good way to do it, right? Mm-hmm. But then being an engineer, if I don't make it to space, because a lot of people try and they don't make it,
right?
You can still make money and live, which I thought was a good thing.
I think a lot of astronauts, at least early on, were like engineers.
Yeah,
right?
absolutely.
Yeah, so you were like, I'm gonna follow in those footsteps.
That's right. That's right.
Got it.
And then I changed my mind later on because I loved engineering so much. I loved electrical engineering so much because of the cool things like this that you can do with it.
Right.
Yeah. So I decided to go the land-based engineer route.
Yeah. Well, today I feel like, and we've asked Chat this before, how many people would go to space if they could. Mm-hmm. And I feel like now we have sort of an environment where you can still do it if you want to. You still can make it happen.
It's not out of the question if I get an opportunity.
Yeah. So I'm coming around here.
Looks like you're making pretty good progress.
I'm making good progress. And what did you have any like early people that mentored you or encouraged you early on?
So, I mean, my very first encouragers were my parents. I was really lucky. I have a great mom and a great dad. And my dad's an engineer, and my mom would have been. When she was coming through school, women didn't get to be engineers. But Mom is actually an English major, which has come in handy too, trust me.
Come in handy for like your writing?
Yeah, because when an engineer has to do a lot of writing, it's not something that people think about, but we do have to do a lot of writing, and we got to be able to communicate very clearly.
Right. I think I'm getting some progress.
I think you're making some progress.
So we're seeing this here. I'm getting in here. I'm getting in there, y'all. I'm getting in there pretty well.
But I had teachers, too, that helped me along. I had a calculus teacher in high school. Shout out to Miss Jansen.
Miss Jansen?
Yeah. I had some folks at university when I went to Virginia Tech. Without Dr. Bostien, I wouldn't be here today, so thanks to Dr. Bostien. And then, of course, when I was an undergraduate student, there were a lot of opportunities for women to date because there weren't that many of us in engineering.
There was a lot of choices available.
There were, and so I found my husband there. And
your husband's an engineer too?
He is an engineer as well.
I don't think I knew that.
Yeah, he's an electrical engineer. Actually, we took one class together, and I got a higher grade than he did, and I won't let him forget that.
And you are his forever study buddy.
Yes. Oh yeah.
I got it, Dr. I got it.
You got it. Look at that.
Right. Here we go, y'all. We are there. You all see that? Dr. B, engineering, yes, is cool. Glad my daughter is watching right now. Yes, shout out to your daughter. Razzle dazzle.
Yeah, let's get that.
Yeah, let's cut that off. Boom. There we go.
All right, so what's inside here? So if you look, there's some glue. There's a lot of glue.
Some glue holding it down to the bottom of the rubber?
Yep. But if you pry it up, the nice thing is you got it open.
Oh, there we go.
It's still working.
So that's a sensor. I got it open. That's what I was trying to do, by the way, chat. In case you were wondering why it was taking me a while, I was trying to like get it open and not destroy it. That was what it was.
Now, when you look in here, the thing that you'll notice immediately, or the thing I notice immediately, is that most of this is the battery. In fact, batteries are our biggest enablers right now.
Okay.
And they're also our biggest thing that hold us back.
Because of the capacity.
Because of the capacity of batteries. So if you want to make a big difference in the world, get into creating new kinds of batteries.
Yeah. By the way, we have a room. We have one night or some puzzles in our escape room around batteries. So again, escape room, plugging that. All right.
So right here is a tiny, tiny little sensor. And so I figured there's no way they're going to see that, but it's just this long and this wide. So instead of...
At the end there, that's
you see that? And
yeah.
all that's in there is a spring.
I see it. It's like, and by the way, I want to make sure. So one of these springs
A little smaller, of course, in there, but
Yeah, it's basically at the end as a part of the sensor. I want to make sure they can see the end we're talking about there. I'm going to pull it up here a little closer to our a close-up. Also, see if you can get a nice little close focus on that. So the battery is there at the end of this sensor here.
the battery's in the middle here.
Oh, in the middle.
The sensor's here.
The sensor's there, but the battery is at the bottom there. That's the battery, and then the sensor's here, which is a spring. It's a much smaller spring, right?
And it's a spring that's basically hooked up to the battery. Let me show. I made an analog here.
Okay.
Okay. So I got just a battery pack, and I connected the battery pack to one side of an LED, and then this side to a spring. So if you hold.
So hold the spring.
You hold that. Actually, you hold this.
Okay.
Okay. There's the LED, and if you imagine the spring is like right here, right? And when the kid jumps up and down, the spring vibrates. And do you see how it contacts the LED and turns it on when it's vibrating?
So that's how it gets the impact, right?
So that's how it works.
Yeah,
exactly.
Yeah.
And of course, if it touched all the time, the LED would be on all the time. But so it's a motion sensor, or an impact sensor, if you like.
This is nice.
And that's how it works.
This is nice. So when the kid is moving, like you said, because these things, I remember I had a pair, Dr. Bottomley, and like they kind of stopped working after a while.
Yeah, they do.
So if they stop working, is it more likely the fact that this spring kind of wears out, or what do you think is maybe?
It could be that, or probably it's the battery's dead.
The battery's dead. Yeah.
I mean, that's a little button battery, and it lasts a long time, much longer than you think it's going to last. But yeah.
So the goal is, so if we were to make our own, right? The goal would be to position a spring here where it's not touching the sides of the LED, but it's close enough so that when it gets impact,
exactly,
like you flick it.
Yep, when you jump up and down.
Got it.
That's exactly right.
Yo, if y'all think that is dope, if you think that is cool, I need y'all to show some love in the chat. Some Dr. Bottomley broke that apart, and we got to destroy some kids' shoes in the process. So. All right.
So the thing that I think about this is that's like way simpler than I would have thought it was.
Very, very much so.
Yeah.
Do they have these too in like, what is it? I've seen like gift cards, like holiday cards or whatever, where they have lights and things like that.
That's right. So a lot of times in a gift card, it'll have like a little push button switch.
Oh, okay.
That'll turn it on, but it's the same kind of thing. The switch is making this push button switch makes a connection and completes a circuit. Yeah. So
if I thump this, do you think that'll?
I do.
There we go. Y'all see that? That's the little basketball player right there on the blacktop. Right there, or the tennis player.
And you make your spring stiffer or looser depending on how easy you want it to light up. Because, see, I don't want it to light up just. I want it to have to be struck pretty hard. Pretty hard.
Yeah. And when you gave another example of how like you could do different patterns of lights and stuff like that.
You could. So if you want, and this actually does have a small electronic chip in there. For those of you that know electronics, it's probably flip-flops.
Okay.
That just cause these to go on and off a couple of times. You see how they go on and off a couple of times? That's how that works. So it's a tiny little chip.
By the way, so chat, if y'all have any questions, make sure you ask them in the chat. We're going to take a look at them, and we're going to get some questions for Dr. Bottomley. But if you remember, for those who saw our customized LED light up with Becky, we had an Arduino.
Oh, okay. Yeah.
And so we programmed a light, kind of a light display or what have you. So I guess let's just say this was some sort of bigger shoe or bigger thing.
You could put an Arduino in there.
You could put Arduino in there.
It'd be overkill.
Okay.
But yeah, you could put.
But you could, and you can make all types of the things that we programmed, that you all saw us program. We could program it in the shoe even.
You could. Well, you could even have a little ribbon going around the shoes with words. Something like that. An Arduino, you might as well go fancy.
Yeah, Arduino, we could have it do our homework.
The same thing to turn it on.
Right. I love it. Hey, shout out to everybody in the chat. We got some more sensors that we're going to be showing you here in a little bit. Peach Alex said, I love the light up shoes when I was a kid. Yes, I love it. Yes, sensors are dope. That's just fundamental science. Everyone loves it. Thank you, Nova, by the way. Thank you for Nova putting some information in the chat, letting us know, supplementing. Great job, Terrablazer. Good to see you. Our building committee member is back here. Good to see you. I love it. And everybody on YouTube, keep the comments coming. If you have any questions, we'll try to catch it and ask Dr. Bottomley. Dr. Bottomley, so this is one type of sensor.
Yeah.
Would you classify this as a what, like an impact sensor?
Yeah, an impact sensor, a movement sensor. You call it whatever you want.
Okay. All right. So what else can we?
Well, I noticed there's a comment in the chat from the Opal guy, I believe it is. I'm sorry, I can't see as well as he can.
The Opal guy. All right.
Yeah. That says if you put a piezoelectric sensor in there, you could use that to generate the electricity, and you wouldn't need a battery.
Ah.
Well, the next kind of sensor that I want to show you doesn't use piezoelectric crystal.
Okay.
But it doesn't have a battery.
Right. It works without a battery. So our credit cards are sensors?
Our credit cards have sensors in there.
Okay.
Right? Because if the chip, right? The ones that have chips in,
right.
which I guess most of them have these days, right?
Nowadays, yeah.
So this is only part, you can only see part of the chip.
Mm-hmm.
Inside this plastic is a whole lot more.
Okay.
So I thought if you'd like, we'll see what's inside this plastic.
Y'all want to see what's inside the plastic? Yeah. Chat, y'all want to see what's inside the credit card that's causing our bills to be as high as it is? Let us know. Let us know. We're gonna see what it is, what sensor is inside this. So how are we gonna do that, Dr. Bottomley? What are we gonna do with this?
I'm gonna drop it in acetone.
Acetone and basically dissolve the plastic around?
Yeah, exactly. So the acetone is basically fingernail polish remover.
Okay.
But I got some stronger stuff at the hardware store this morning.
Okay.
So it takes a little while, but we got that in there.
We got that cooking.
Yeah. So while it's cooking, let's talk about how it works.
Okay. All right.
So what we're going to find inside there is a coil of wire.
Okay.
Right, a coil of wire like this coil of wire here.
Okay.
Okay, and not a whole lot smaller than this. It's a little smaller gauge than this, but similar to this.
Mm-hmm.
And this coil of wire is what is the sensor.
Okay. Is it like a circuit? Oh, I mean, we'll see.
It's not. It's just a coil of wire.
It's just a coil. Okay.
What it's doing is sensing electromagnetic fields.
Okay.
You familiar with electromagnetic
fields? Yes, I am. We did a little bit of fusion. Y'all remember we talked about fusion? So I am a little familiar with electromagnetic fields. Yeah. So it's creating a field with that wire?
No, the wire's not creating the field. It's detecting the field.
It's detecting the field. Okay.
Right. So I've got this device right here that will that'll create an electromagnetic field.
And this is a coil around it.
It's a whole bunch of coils of wire wrapped around this thing, yeah. And it's plugged into the wall. Okay. So when I turn it on, the current just goes through this up and down.
Up and down. Now let them know what this thing is, because I know that like people are probably wondering if they could get this at home or whatever.
You can. It's called a Tesla coil.
A Tesla coil.
You can get it at home, and basically it's a coil of wire and two huge capacitors down here, which are capacitors are energy storage devices. So they store up the energy so that they can really boost the ability of this coil to carry energy, if you will.
Got it.
So when I turn it on.
I don't know. Oh, whoa. Can y'all see it? Right now. Nova got me covered.
There's a little piece of lightning in there. It actually happens exactly like lightning happens.
Wow.
Right? That's not, so Nikola Tesla was the guy that invented this.
Yeah.
And he didn't invent it for the purpose of making the electrical arc, although the electrical arc is fun to play with. Mm-hmm. He invented it to create the electromagnetic field, and the electromagnetic field that's in the air around this is invisible. Okay? And it happens because anytime you have electricity moving through a wire, you get an electromagnetic field in the air around it for free, as if...
For free?
Yeah.
Okay.
So because you can't see this, and you can't hear it either, the sound that you're hearing, if you're hearing this, is the electrical arc here, which is like thunder, basically.
Oh,
okay.
Can y'all hear that? Can y'all hear the arc?
Can you hear the arc?
Maybe I can put it close to the mic and hear it.
Yeah.
Y'all hear that? That's the like really quick question. If you touch that, you'll get shocked, right?
You get burned.
Ooh.
Yeah, because it's really, really hot. So electric arcs are hot. Mm-hmm. We use them to weld.
Oh, right. So
you wouldn't actually. The shock is if the current flows through your body.
Oh, okay. That's shock.
But because they're so hot, it'll
burn you. Okay.
You can actually. I can set paper on fire with this electrical arc.
Okay, gotcha.
I'm not going to do that.
We're not
going to rented space.
We're not going to do this here. Yeah.
But yeah. So I just want to show you the electromagnetic field here. So what I'll do is I'll give you this electromagnetic field detector here.
Detector? Okay.
Yeah. And then I'll hold this, and you just find the electromagnetic field. So
okay, what do I do? I just wave it over?
Just find it, and you'll find. Yeah, there you go.
Ah, so I'm within the field when the light comes on.
Exactly right.
Ah, is this like plasma on the inside?
It is. That's plasma on the inside.
So, listen to that. Okay.
So this is a neon. This glass has neon gas inside of it, and so the energy in the electromagnetic field makes the neon glass glow red. That's why I chose neon.
So if I get close to it, it did a little.
Yeah.
What's that?
Oh, it's arcing to the bulb.
Oh, okay. You're so brave. Y'all see it? All right, so I want to give us another shout out. We had an opportunity to go to MIT Plasma Science and Fusion Center. So shout out to MIT, and we were able to check out some of their, I guess, larger. What are these called again? I can't remember.
Like plasma tubes?
Yes, plasma tubes. Okay. Nova, drop that in the chat if you will. But this is really neat. So if you get closer,
I just think that this is also super interesting.
Oh no, this.
Can you see it's activating the shoe too?
Oh, the electromagnetic field.
Yes.
Look at that, y'all.
So it's conveying power to the shoe. The shoes, these LEDs are not connected to the bulb.
No, they're not.
There's nothing shaking this enough to make that connection. It's actually conveying power to the LEDs through the electromagnetic field.
That is crazy. So this is how they were able to figure out communications and stuff too, right?
Yeah, that's right. And a receiver. I just have to turn it on and off in some kind of pattern.
Got it. Is a receiver similar to a sensor in some way?
It is in a way, because it's sensing the because what happens in an antenna, like in your phone or something like that, is the electromagnetic field makes an electric current in the antenna, and that's
it's sensing the electromagnetism.
Exactly right.
Got it. That is amazing, y'all. I need to see some love. Let's see if we can get some questions. A lot of people are loving it. Let's see. Yes. Oh, okay. It's messing with the electronics in the room. You can hear it. You hear it. Yeah, but it's all right. Hey, listen. If you all have any questions, please get it. Oh, the glass.
Here. Put this over here. So, when I touch the glass, it interrupts the way it lights up at the point of contact. Have you ever seen those bulbs that have like these purple lightnings, and when you touch them, the lightning comes to your hand? It's happening. That's exactly same.
Okay.
My hand changes the way the field operates.
Got it. And this is airtight too, right?
It is airtight.
It just has the gas in there. So right now we have the credit card, y'all. The credit card that has a sensor sitting in the acetone as we try to get it to break down. I see all the paint and things coming off of it, but that it's going to eventually reveal how there's a coil of wire, which is created to be able to sense the.
Now let me show you what that coil of wire is doing.
Okay.
So here's the coil of wire.
All
right, and I've got it. I've got this big magnet sticking to everything. Okay. Here's the coil of wire. And I've got this coil of wire hooked up to a multimeter here. Okay. I just want to be able to.
I can touch the coil, right?
You can. Yeah. There's not enough power. So if you could see the multimeter, what I'm going to do is I'm showing you the voltage. So voltage is not the same as energy, or it's not the same as power, but it's also but it's related to that.
Got it.
Okay. So we're measuring the voltage, and you can see right now it's just a coil wire. There's no voltage. There's no energy source in this system right now. Okay. So if I turn on this field.
Okay.
All right. And then you.
All right. So
if you want me to do it, if it's going to make you nervous.
Well, I'm hanging in there. I'm getting more confident with you here. But what else? What are you going to do? Are you getting close to?
Look at the meter.
Let's go there. So the meter is going up. Let's see if we can zoom out a little bit. So now the meter is going up as a result of this coil getting close to the.
Yeah. So when the coil gets close to the, you want to hold this maybe?
Hold this, lift it up. Okay.
Yeah. And then when the coil gets close,
The meter changes.
The meter changes.
Yeah.
So the coil is detecting the field.
Ah.
It's sensing the field.
Yeah.
And the reason this works is because an electromagnetic field causes a current in the wire. Mm-hmm. Just like the current in the wire causes an electromagnetic field.
Oh.
So this, got too close, it shocked me.
Okay.
This one is, this wire right here is causing the electromagnetic field, and then this wire right here is sensing the electromagnetic
It's sensing the field. Okay.
Yeah.
Are there like ways to like visually see this? Because this feels like magic. It's almost like where I heard the quote about how like significantly evolved. Who quoted that? Nova. It's like we're not seeing it. We know it's there. We know
it's there, and we see it, and I think that's why some people are scared of electrical stuff, because they. Now I don't know if this is going to work.
You don't know? Okay.
So if this coil will generate enough energy to light the LED.
Okay.
But I don't know if it has, because there are not very many turns in this coil, right? I just did 5.
How does the turns affect the energy?
The more turns you have,
yeah,
the more current it gets generated.
Oh, okay.
Okay. So in this case, an LED doesn't take a ton of current, but look at that.
There it is. It's lighting up.
I don't know if you can see in front of the black.
That's a lot of.
And
it's still lighting up the shoes too.
It's still lighting up the shoes. So it's generating enough energy to light up the LED.
Got it.
Does that make sense?
Yeah, it does.
In a sense, there's no battery in this system at all.
Mm-hmm.
We are scooping energy out of the air. With our coil, right?
Right.
And that's basically how an RFID tag works.
Got it. So that's why we don't need a battery, y'all, for our credit card. That's why we swipe it, and it's good to go because it's able to pick it up.
Yep.
What are those sensors called again? It's called
an RFID.
RFID.
Radio frequency ID.
There we go.
So let's see what we got in here.
Let's see if we were able to break down the credit card.
Of course.
Truth of the matter is, some of us need to drop our credit cards some acetone as well, because I know some of y'all chat out there.
You might want to think about that. Some of us
y'all might be spending too much. We might need to break down your sensor.
So I haven't. It's not quite apart, but you know what?
It's very soft though.
It's really, really soft. You can see that.
Okay.
But I tell you what.
Let's leave it in there, Kim.
We're gonna leave it in there. We can check at the end.
Check it in. Okay, cool.
But I put one in there earlier.
Okay.
Okay. So this is one that's earlier, and here's where the little chip is. And it opens up. Right, and then inside, what you end up with is this.
So that's what you were showing here.
So here's the chip. But you see the coils of wire? There's a coil here, and then there's actually a coil that goes all the way around the outside of the card. And that coil of wire senses electromagnetic fields.
Yes.
It generates a current that's enough to power the tiny computer chip that's in here.
Right.
Which is here. And then this tiny chip has been pre-programmed.
Okay.
And what it does when it gets power is it broadcasts through an antenna.
Where's the antenna? At the store or?
Here.
Oh, is an antenna on this?
Yes.
Oh.
It broadcasts through the antenna, and then at the store, when you wave it near the device, there's a receiving antenna in the device that receives what this broadcasts. And what this broadcasts is, this is credit card number, blah, 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 blah.
My bank account number.
Belongs to Laura Bottomley, et cetera.
That is crazy science.
Yeah, so then the device decides whether or not to allow me to make that purchase.
Right. Yeah, or in some cases, insufficient funds.
Yeah, sometimes. Yeah, but there's no battery in here. It's generating its own power.
That's the amazing part. Yeah, so you're saying that the sensing of the field produces the power.
It does.
Creates the current, rather, that gives us enough power to operate.
Yeah.
But without that, it doesn't work.
No, it wouldn't work.
Okay, got it. And so why do people, is there a reason why we don't want to get this too close to other things?
Yeah, so if you get it too close to a huge magnet or something like that, the field can have too much power and mess up the chip. It could burn out some of the connections.
Got you.
Okay.
Got you.
Also, in case you wondered how close like can somebody walk past me with a receiver and broadcast? You got to be within 4 centimeters of this.
Oh, okay.
So you've got to be within 4 centimeters when you wave it.
Yeah.
Right?
Yeah.
But the people that steal stuff
information,
have a bigger broadcast. Right, so they broadcast more power.
Okay.
That's how. But a way to protect this is you can buy these special wallets
that like block the field,
or you can just wrap it in aluminum foil.
So aluminum foil will protect it.
As long as it's a closed metal surface.
Got it. She's telling us some life hacks, y'all. We're getting some life hacks as well. Protect your credit card information if you want to. If you're really worried about it, wrap it in some aluminum foil, and that'll basically disrupt the current or the field
and
around
those RFID tags are in a lot of different places.
Like where?
Well, like here.
Oh.
This is from when I went to where'd I go? I don't know. I went to Atlanta. And this was the luggage tag.
So they have where? I mean, what
There's
do you mean?
There's an RFID tag in here.
Inside of the. Get out of here, y'all! Chat. Do y'all see that? So right inside of your luggage tag is an RFID sensor.
It's a tiny little sensor, yeah.
RFID sensor is inside. I thought it was just a piece of paper. I literally thought it was just a sheet of paper. Y'all, this is cool. If you have any type of questions to ask, please drop them in right now because it's blowing my mind right now. Thank you so much for Nova dropping the information in there so everybody can see. Awesome. So right here, that is the same thing, right?
It is the same thing. And so what this gets programmed with is that this is my suitcase. Right. So this is how the airlines that track your bags do. Like my airline, I've got an app that'll tell me when my bag's getting loaded on the plane. Mm-hmm. Right. And that means usually it's like an arch that they go under, and that arch is broadcasting an electromagnetic field, which activates this RFID tag to broadcast that this is my suitcase.
I didn't know. So does that have anything to do with the barcode? Because I thought it was all about the barcode.
Well, the barcodes are another way of doing it.
Way, okay.
But
it's really
if you use a barcode, somebody has to manually scan all those suitcases.
Yes.
Right? But if you use this, it can just simply be done automatically
it just
as
passes
it passes
through.
by.
That's efficiency too. Man, you about to make me wish I changed my major. This is really awesome.
And then there's another place. So this is my North Carolina Quick Pass toll payer thingy. Yeah. And so I broke this open.
Oh,
and inside here is another RFID tag. Mm-hmm. Okay, but this is a little bit more complex. So it's got the RFID tag, but it also has a battery.
Because it needs to power.
Because it needs to power, so it needs to be able to. So what happens is, see, this says antenna. It's a tiny little antenna there.
Okay.
So when you go under a toll plaza, it's big. You go under it, it's broadcasting an electromagnetic field that gets received by this antenna, which activates this chip to broadcast. Okay. But to broadcast, it has to broadcast stronger than your credit card
quicker,
chip.
right? Like it's
it's at the same. It happens nearly simultaneously.
Oh wow! Okay.
Yeah, but that's why it has a battery in it, so that the battery can boost the signal, so that the toll plaza can receive
this thing is because we're driving under the little what is it? Those are senders or transmitters.
It's a transmitter.
So transmitter
and a receiver too, I guess, because it has
to get both. Yeah. And it can send enough to be able to activate that, but then it needs to have the power so that it can send it back with
correct
enough. Okay.
Yep.
To get back to the
yeah.
Man, it happens like that too.
It happens like that. Wow. Exactly right.
I always thought I can get by sometimes when I'm out of town.
You cannot. You
can't
I'm
get
sorry.
By. Oh man. All right. Well, hey, listen. I hope you all are enjoying this. Shout out to that Opal guy. Sounds like let's see. Could a wallet with Mylar threads be enough to disrupt the field? You know what Mylar threads is?
Yeah, so Mylar, I don't think that Mylar will disrupt it. I'm not sure. Maybe our fact checker can check on that for us because Mylar, is Mylar a conductor? That's what I'm not sure.
Yeah, Nova, let us know. Help us out, Nova. Is Mylar a conductor? We want to answer that Opal Dies question. I see a couple others. What's the difference between NFC and RFID? You know, what is NFC? Does that ring a bell? Dr. Lord Bottomley. People are. NFC. Shout out to everybody on Google. I'm loving that you all are engaged. People are really getting engaged. A lot of people dropping. Jay Simp said, "I'm learning so much today."
Oh, so these RFID tags can be damaged.
Yeah.
But see how it's so tiny. It's hard to damage it. And these are really tough, so they don't tear very easily.
They print them out, though. I see them print them out.
They do.
They're able to get them so small and thin enough that they can print them out.
Yep.
And they're already programmed.
They are. Yeah.
And so they're basically like, hey, this is Dr. Laura Bottomley's luggage. Okay.
Yeah. Mylar's an insulator. Yeah, so I don't think Mylar will work, although that'd be an interesting thing to check.
Hey, that's another experiment. Shout out to you over that question. Let's see. Still about mass changing the name of Easy Pass. somebody like that. All right. Hey, if y'all have any other questions, keep the questions coming while we have our guests. And we're still cooking here. That's going to be done in just a little bit.
Yeah.
But I think there's another. You showed me something. You walked in with something, and I don't know. There's a love-hate relationship with this device here,
this
but it has
device
sensors.
right here.
Yeah, the scale. Dun dun dun. The scale. Okay, so the scale has sensors in it, right, Dr. Bottomley?
It does. So the scale has sensors in it that are so is where this one, you could have called this a pressure sensor.
Oh, okay.
It's really more like a accelerometer, meaning it detects a change in velocity.
Velocity. Okay. Yep.
But these really are pressure sensors, and so this particular scale has 4. I suspect a lot of them have 4, 1 in each corner, so that when you stand on it, this one, and this one measure how much pressure it experiences, adds it up.
Yeah.
And that's the weight.
That's the weight.
So you calibrate it so that the output of this gives you the weight in pounds or kilograms, whichever one you want.
Is the sensor at the top, or is it more at the bottom, or is it just in the middle?
I think it's in the middle here.
Okay.
I think it's inside of this thing.
Okay.
Yeah, I don't know if we can get that off. We might be able to get that off.
I don't want to tear up your.
I do want to tear up my scales.
Maybe it start cooperating, right?
Yeah.
Did y'all know that? So here, these are all sensors here, these 4 corners. When we stand on it, it adds it up, and the calibration of it is what allows us to know what our weight is. All right.
And one of the things I like about this, pressure sensors like this are incredibly easy to build.
How are they built?
Well, you probably have everything you need at home.
Okay. Let's see.
So you need a piece of copper. So this is a circuit board, because that's what electrical engineers sometimes have around, right?
Right.
But you just need a piece of copper. Like
Got it.
this.
And this is,
okay?
if I didn't know copper, I thought it was more metallic than this.
It is. So this is the metal. It's copper that's been laid down on top of some epoxy circuit board.
Got you.
Okay? And then you also need some squishy foam of some type. And then you need some black foam of this type. Have you ever ordered anything that came with this black stuff?
Oh, that's good. Yeah, this is what you put inside of your shipping boxes.
Yeah.
To make sure that.
So this is, you frequently pack electronics in this black foam because it protects the electronics from static.
Right. Okay.
Because it turns out this black foam is impregnated with carbon, and it's conductive.
Didn't know that. I thought it was all about just physically protecting it, but this is...
Now, this is actually to leach off any electromagnetically generated current that might appear.
Electromagnetic, things just kind of...
Of course, we're surrounded by electromagnetic fields all the time.
Yeah.
I mean, there's lights up here. They're lighting because of fields. I mean, anytime you have moving electricity, you have electromagnetic fields.
And if you didn't have this, I guess your electronics could get to you and not work because
That's correct.
they've been so disrupted. Okay.
That's right.
All
Yeah.
right. I'm learning a
so
lot.
these 3 things are all we really need. So we can build.
What kind of foam is this again?
That's just any old foam. I got it. It's kind of stiff. It's a little bit like the foam that's on the bottom of the shoes. Honestly, I just found any old foam. I wanted something about the same thickness as this.
Okay, gotcha.
That was my choice.
Right. Okay, cool. Okay. So copper, the insulator foam, and then just any old foam.
So you want to make a sensor?
Let's make it.
All right, cut me out a square of that.
A nice square.
About an inch square.
Square inch. Got you. I know about a square inch. I'm a structural engineer. Shout out to the structural engineers out there. Pounds per square inch is our thing. That's our thing. All right. So get me a nice little square inch. I'm leaving enough room for clearance for you, so I'm a little bigger.
Yeah. See. All right. All right. Now I need this cut in half.
Just cut in half.
But
Same
wait.
thing?
Before you cut a circuit board like this in half, you really need to wear safety glasses because it might.
PPE. Get your PPE.
Yep.
All right, so
All right,
cut this
so
in
just
half.
cut it in half.
And I need the glasses because it might...
It's going to spit up little pieces.
Okay. Don't spit up. Oh, yeah. There we go.
Okay.
Okay.
Good.
Does it need to be the same size?
Nah, that's good enough.
Okay.
if you want your sensor to be like really, really accurate, and you want to calibrate it and all that stuff, then be a little more careful about getting stuff the same size. But okay. Next thing you got to do is take this foam and punch a hole in it.
Punch a hole.
Punch a hole about a third of the way in.
Okay. DIY sensors that we got going on. All right, here we go. About right there.
Yep, that's good.
Bam.
Okay, good.
All right.
So we got a hole in there now. All right, now we're going to take the black foam, and I already cut a piece of black foam.
Okay, you already got it. All right, cool.
Just to save us a little time, and you're going to punch a hole in the black foam too.
Okay.
But I'm going to clean out our hole punch.
The squishy foam out
Okay,
of there.
here, get us a good punch of black foam there.
Nice little. Get it in here. Boom. There we go. There we go.
Now I don't care about that piece. What I want
you want
is this piece. Hold your hand up.
Oh, you want the little piece that we punched out.
The little piece that we punched out.
There it is, y'all.
I want you to put that little piece in that hole.
Okay, got you. So we're essentially replacing a part of this foam with the other foam. Right? Is that good?
Yep. And now you just put the conductive side, the copper side, in the middle of this sandwich. Okay?
Okay, so the copper's facing inside.
Yeah, so the copper's facing inside, and this is our sensor.
Got you.
Okay? Now, how are we going to tell if it's our sensor? What we're going to do is we're going to connect it up to our friend, the multimeter again.
The multimeter?
Yep.
And by the way, break down like this multimeter, because it seems like a go-to tool or device for...
Well, it is, because you can measure DC voltage, you can measure resistance, which is a measure of how good something conducts electricity.
Right, okay.
How good. That my mom would kill me for that English. Just work with me on that, all right?
I'm with you.
It also can measure AC voltage, which is the kind of voltage that comes out of the wall. DC is the kind that comes out of a battery or something like that, right? And it can measure DC current. So voltage is like the push,
right?
And current is like the flow.
The flow.
Of electricity.
Yeah. I think we talked about that a little bit too, chat. By the way, so make sure you all check out some of our.
That's good. Yep. So we're going to take this one and we're going to clip it to the sensor.
Okay.
Okay. And what we're going to measure is actually the resistance of the sensor.
Okay.
In other words, how well could it conduct electricity?
Do you need this? You need this here? Okay, those are...
I'm just making it easier to connect to our multimeter.
Oh, that's what those are. Okay, got you.
These are just alligator clips that I like because they...
Is it red on... Are we doing it right with red on black?
It does not make any difference.
It doesn't make any difference?
No.
Oh, okay, yeah. I'm over here thinking about jumping my car and thinking...
Yeah, it makes a difference.
All right, so we got our wires connected to our copper plates, which is conductive.
So I'm measuring resistance. In other words, so this right here, it's like a 1, but it's far to the left.
Yeah.
That means that's the symbol for infinity. So there's no electricity that can flow.
Okay.
But if I press on the sensor...
So you're pressing where the hole... Is it more about where that hole is?
Yep.
Let's see. So that hole is...
Turn this. The hole is
there it is.
Right there. So that's where I'm going to press.
All right.
And if this sensor doesn't work...
Then that mean I made a bad sensor?
No, what I think is that we probably need a little bit more foam in there.
A little more foam? Okay.
It's okay, I made one earlier.
Okay. So we got to...
So I stuffed actually 2 holes worth of foam in there.
Got you.
Just to make sure that I get good
filling.
Good
there it is. Look at that.
Yeah.
It's already...
So now
the number is changing. It's not 1 anymore, chat. Y'all see that? It's not 1 anymore. Here we go.
So it's high. The more I press, the lower it goes.
So what does that mean? They said Dr. B came prepared. They said,
I've done live television before. I know.
Yes, absolutely. So what is that? How does, again, fill in the gaps for, again, how increasing that allows it to operate as a sensor?
Yeah, so what's happening is as I press on this and this goes, the resistance goes down, that means that electricity could flow through here.
Right.
Okay.
Got you.
So if instead of connecting it to the multimeter, I connected it to a battery
Mm-hmm.
and an LED.
Mm-hmm. Mm-hmm.
Then, and I press it down, then there's less resistance, then more electricity could flow. The
flow
battery
through.
would,
Yeah.
the LED would light up.
So, all right. So let me see. If I want to do something more complex then, right,
Mm-hmm.
and I had like an actual chip or some kind of processor, I would basically program it to where it knows the amount of electricity that's going
Correct.
through and say, hey, if it comes at this level, then do this. If it comes
Well,
at
that's
that
right.
level.
So what all I need to do would be to take this measurement like this,
Mm-hmm.
and then measure how much force I'm using to squeeze. So
And then correspond basically your force with the
exactly,
the
and that
resistance.
would be the calibration that we would do.
Gotcha.
And that's what the scale has done.
Oh, okay.
So the scale knows that when this resistance is a certain amount, that corresponds to this many pounds sitting on that sensor.
Got you.
Now, it's not really that the scale, quote unquote, knows the resistance,
Uh-huh.
but if you have an electric circuit with 4 resistors in it, then as long as you're able to detect the voltage,
Right.
right, that's in the current that's flowing through the circuit,
Yeah.
then you can determine how big those resistors are.
Got you. And so they all almost sort of form some sort of redundancy among each other too. Is that kind of too the case?
They could be sort of redundant, but the
Okay.
purpose of having 4
Uh-huh.
is so that you sort of spread the weight out.
Right.
Because if you have all your weight on one sensor, then that sensor has to have a much wider range of ability to sense weight.
Okay.
Yeah.
Gotcha. And then if inside the let me get the scale really quick. Inside the scale at these corners, is it a different material or a foam likely case sometimes? Is it foam?
So it might be foam or it might be something else. It'd be anything, and there are multiple kinds of things whose resistance changes when you press on
When
them.
you press on it, yeah.
Yeah.
That is amazing, y'all. Make sure you show some love, Dr. B. This ain't my first rodeo. People were laughing about how you were prepared. Some of this will be good for the escape room. That's right, absolutely great for the escape room. As a matter of fact, before I forget, let's drop the link one more time. Shout out to everybody on YouTube, everybody that is on Twitch as well. We're gonna drop the link one more time because we are accepting applications for you to come and be a part of our live escape room. Now, we're going to do it both virtually and in person, which means that people are going to be able to participate, Dr. B, through chat. They're going to be able to help give clues and help solve puzzles. So there will be a virtual component.
Oh, that sounds like a lot of fun.
I know. I hope you're there. But if you want to be considered to be a player or a participant, to come over to Boston, stay in a hotel, meet Dr. Nee, meet the NOVA team, meet Trapology. Shout out to Trapology who helped us design the escape room. Make sure you look at that link that NOVA is now dropping in the chat on our Twitch channel. And if you're on YouTube, come over to our Twitch channel because we want to see your application. Dr. B, what do we have now inside of our acetone?
Oh, it's done.
It's done? Okay.
Mm-hmm.
All right. That thing is gone. Wow. So this is, oh, that's the plastic, right?
Yep, it's the plastic.
And inside
It's
the
hard
plastic.
It's slippery
I
plastic.
know, I can use these pliers if I need to get it.
Okay. So inside, here's
So
all the plastic.
The coils.
It's dissolved, and if you take it apart,
Yeah. Those are the coils inside right now.
you see the coils inside right now?
Yeah.
Yeah.
This is nice. It's nice as in like revealing. You know what I mean? Shout out to you. We see you, Rose. Shout out to Rose. It's good to see you. That Opal guy always hanging out with us. Arjuan, Nova, thanks so much for dropping the application. This is amazing. I need you all to do me a favor and thank Dr. B in the chat. Make her know that we really appreciate her coming on to building stuff with Nova. I don't know if there's any questions. We're going to see really quick if there's any questions. If anybody want to drop a quick question. But if you don't have a question, please just show some love. Somebody said shout out to acetone.
Yeah, dissolving all our mistakes. I wish. I wish.
I love it. I've enjoyed this like thoroughly as well, Dr. B. And I'm just wondering, as we get ready to close out here, if you could share just some parting words of wisdom. I'm gonna let you think on that for a second. Now, while she's thinking on that, and I'm gonna take a moment to see if y'all have any questions, let me make sure that I can share with you all what's coming up for the remainder of this week. Now, don't forget that we have one more stream for this week. We have a Minecraft stream that's going to take place tomorrow. We had a lot of fun on what was it, Monday? We had a lot of fun on Monday when we were playing in Minecraft building stuff. Shout out to our co-op, Nova Co-op, Kajo, who was helping out. We're going to do Minecraft tomorrow, 1 p.m. Eastern, same time, same place, but only on Twitch this time, only on Twitch. And then next week, we're going to come back with a whole new slew or slate, if you will, of programming. Now, we're going to also have 4 p.m. be our time early in the week next week, because we want to continue to see how that time works out for some of you who could do better at that time of day. But then towards the latter part of the week, we're of course going to go back to 1 p.m. So make sure you set your watches, because we come to you every day on Building Stuff with Nova. Today was no exception. Today was a great day. As we get ready to come back to Dr. B, let me see if there are any questions before I move on. But I won't belabor this, Dr. B. I just want to go ahead and ask you if you can go ahead and give us some parting words
Sure.
of wisdom.
So I will tell you that I'm using the word detector and sensor interchangeably.
Okay.
Because all sensors are actually detecting something.
Okay.
And then we use that information in whatever way we want to.
Mm-hmm.
So, but my parting words of wisdom would be this. I know people can be intimidated by sort of the things that are around us these days.
Yeah.
But they're really not that complicated. Because we broke this stuff down, it was really not that complicated. Mm-hmm. You may need to learn a little bit of electrical engineering, but that's okay. I want you to come be in my class anyway. But there's nothing here that is so complex that you can't understand it.
Right. Well, there it is. Round of applause. We see it coming in the chat. Everybody said yes. Everyone's excited. Thank you so much, Dr. Bottomley. Let's say thank you to Austin behind the camera right now, showing us some love. And thank all of you for being a part of this community, being a part of Building Stuff with Nova. We just love you all, and we just hope that, again, as you continue to learn, as you continue to grow, and everything as you're doing, make sure that you continue to build. And we will see you later. Take care, y'all. Peace.